polynomials. What are polynomials? Polynomials are like sum of power functions. So if you have, say, 4x to the fourth minus 5x cubed plus 2x plus 1. Notice that I didn't put x squared. That's okay. If you have some of these things, and if you have a constant and x, and then other ones are just power functions, right? Actually, this is a power function too, because it's some number times x to the first power. And even the constants are called power functions because it's 1 times x to the 0th power. Oh, by the way, there's one thing that I should have added. It's power functions whose powers are non-negative. You can have 0, but you can never have negative. So if you had like 1 over x squared, that's not a polynomial. That would destroy this being. This would, if you have something like this, it will disqualify the function from being called a polynomial. Okay, you can't have. So I just realized I'm getting ahead of myself. Does everyone know that x to the negative 2 is same as 1 over x squared? Okay, yeah. It's something that you learned in algebra too, but some of you might have forgotten, so I'm just saying it. So see, if you have something like 3 times x to the negative 2, which is 3 over x squared, this is actually another example of a power function, okay? It's still a power function. But if you have this in your function, it disqualifies the function from being called a polynomial because it's a negative power. You can't have fractions, in other words, okay? So polynomials are functions where you can't have fractions. Let me ask if you know this. What square root of x has x to some power? You know?
X squared.
Square root of x is x to what power?
Squared.
1/2 power.
Oh,
Yeah, 1/2 power. So this will be the case when it's a power function, but it's not an integer. Okay. So what's a polynomial? Polynomials are functions that look like this only. You can't have fractional powers. You can't have negative powers. In other words, you can't have fractions. You can't have square roots or any kind of radicals. Those are not allowed. Okay. If you have any of those, it will disqualify the function from being called a polynomial. Now, why do we like polynomials? Well, because they're relatively easier than the other kind of functions. It's like the next step you take after you've learned quadratic functions. See, after we covered functions, we started with linear functions, the simplest function of all. Also, in real life, in business world, the most useful one. And then quadratic functions, that's also pretty useful too. You have seen the revenue one. And then after that, if you want to start thinking about more complicated functions, then here comes the cubic function, quartic function, fifth power function, and all these. They all become polynomials. Okay. After you understand these, then you start understanding these other kind of functions, the radicals and rational functions. We're going to do that later. Okay. All right. So let's think about this. What is the end behavior of polynomial functions? Well, there's something that I didn't explain to you what an end behavior is when I explained it. So if you have y equals to 4x to the fourth, I know that x to the fourth is like this, and 4 just makes it stretch, so the end behavior of this 4x to the fourth is like that, right? But what is end behavior really? It means I want to know what happens to the value of function as you go right. So if you plug in like 100, 1,000,000, then you want to know the value. And basically saying this means that the bigger the value you plug in, the larger the output would be, okay, as you go this way. Doing this would be, if you plug in a large negative value, the larger the value would be, okay? Yeah. So it's like this. All right. So end behavior really is about what happens when x is a very big positive value or very big negative value. So let's think about what happens to this function when x is a very big positive value. Now, suppose you plug in 10. This will be 10,000. This will be 1,000. That will be a 10. So of these four values, which one's the largest? 40,000. This would be the largest if you plugged in 10, right? So we call this the leading term, okay? The leading term is the dominant one, okay? Yeah. So when you write the polynomial in an order where the powers decrease, the leading term is a dominant term because it overpowers everything after. If you plug in 100, then the contrast is even bigger. Like just like how we complain about the economy, like the rich get richer and the poor get poorer. So if you plug in bigger and bigger numbers, this becomes a lot bigger than the other ones. So at some point, this is the only one you care when you think about the end behavior. So what I'm trying to say is that when it comes to end behavior, what do you only have to check? Only the highest order term. That's the only thing that you have to consider. Okay. So the leading term, the 4x to the fourth, this tells you the end behavior of this entire function. What is the end behavior of this function then? Yeah. Okay. Yeah, is that good? So that's the end behavior. Since I was only doing hand signs, let me try to write it down. So the end behavior is, that's how I would write it. Okay, that's the end behavior. Yes?
Would it change anything if the 5 was positive?
It wouldn't. These other ones,
They don't matter.
they wouldn't matter because once x is really big, they don't contribute much. Now, another way to say this, slightly more in a technical way, is that if you call this function as f of x, then you can say limit of x going to infinity of f of x is positive infinity, and also limit of x going to negative infinity of f of x is also positive infinity. So whether you go right, whether x, as you go right, the value goes to infinity. As you go left, the value goes to positive infinity. All right, let's do another example. What's the end behavior of f of x equals to negative 5x to the 7th plus x to the 4th minus x plus 100? I wrote a lot of things, but what's the only thing that matters when it comes to end behavior? X to the 7th, negative 5x, so this is the only thing that matters. Okay, it's odd, so it's either this or that, right? Okay, which one is it?
That one. One you just did.
Yeah, okay, this one, yeah, right. Okay, because of the negative sign, right? Okay, so the end behavior is this and this. That's the end behavior. Now, can you write it in this form? As you go right, what happens to the function? Goes down, right?
Yeah.
What should I write?
Down.
Negative infinity. How about this? This is good because as you go left, it goes up, positive infinity.